Today we're going to look at the double angle identities. Now again, they're at the top of our paper. You don't need to memorize them. They are all on your reference sheet for your Regents exam. One thing to notice is that the cos double angle formula has three options. And for now, it's not going to matter which one we use. We could pick. But sometimes it does matter, especially when we solve trig equations. So you'll see in the next unit why we have to choose one of them over another. But again, today it doesn't matter. So it says, for each value of theta, use your double angle formulas to find sine, cos, and tan 2 theta. So let's look at the 330 degrees. Let's find sine 2 theta. I know the formulas have a's in them, but it's the same as thetas. Anywhere I see an a, I'm going to replace it with 330 degrees. So it's going to be 2 sine 330 cos 330 if I'm doing the sine 2 theta formula. Just like before, we type one piece at a time. Sine 330 is negative 1/2. Cos 330 is radical 3 over 2. Numerator's 2 times negative 1 times radical 3 is negative 2 radical 3. 1 times 2 times 2 is 4. This reduces to negative radical 3 over 2. Cos 2 theta. You pick any one. Let's just do the first one for practice. So it's going to be cos squared of 330 minus sine squared of 330. When you type them in your calculator, you type cos 330, close the parenthesis, and then hit the squared button. When you do that, you get 3/4 minus sine of 330, close parenthesis, squared is 1/4. 3/4 minus 1/4 is 1/2. Now let's do our tangent one. Tan 2 theta, we're back to only one option. It's going to be 2 tan 330 over 1 minus tan squared 330. Tan 330 in my calculator is negative radical 3 over 3. 1 minus tan 330 squared is 1 minus a third. Negative, or 2 times negative radical 3 over 3 is negative 2 radical 3 over 3 and over 2/3. This reduces to just a negative radical 3. I am going to leave the radians one for you. You do the same thing. You use your three formulas and find sine, cos, and tan of 2 theta. For each given function value, find the three double identities and also the quadrant that 2 theta lies in. So we have tan of theta equals 3/5. What I'm going to do is I'm going to make a triangle. If tangent is 3/5, I'm going to call that my theta. I know opposite needs to be a 3 and adjacent needs to be a 5. To find the hypotenuse, I can use the Pythagorean theorem. So it's going to be 3 squared plus 5 squared equals x squared. 9 plus 25 equals x squared. 34 equals x squared. Take the square root. X equals the square root of 34. Now I can find sine 2 theta, cos 2 theta, and tan 2 theta. Sine 2 theta from the formula is equal to 2 sine theta cos theta. Well, look at your triangle. Sine theta is opposite over hypotenuse. So it's going to be 3 over radical 34. How do I know that's positive? You should be saying because it's in the first quadrant. Everything in the first quadrant is positive. Cos of theta is adjacent over hypotenuse, so 5 over radical 34. 2 times 3 times 5 is 30. Radical 34 times radical 34 times 1 is 34. This reduces to 15 over 17. Cos 2 theta, you can pick any one you want. I'm going to pick the second one for practice, which it says it's 2 cos squared theta minus 1. So it's going to be 2 times, cosine, remember, was adjacent over hypotenuse, so it's 5 over radical 34 squared minus 1. When you type that in your calculator, you get 8/17. And finally, for tangent, tan 2 theta, it's equal to 2, and then it says tan A. Tan is opposite over adjacent, so 3/5 divided by 1 minus 3/5 squared. Type in your calculator carefully, please. You get 15/8. Now, since the answers for sine, cosine, and tangent 2 theta are all positive, the quadrant that 2 theta lies in is in quadrant 1, because everything will be positive in quadrant 1. You can also try the other problem there, so please do the problems that I skipped at this point.